Algebra 2, Set 4, the distributive property, solutions of equations, and change sides, change signs. Okay, so when you have something that looks like this, 3 times the quantity 4 plus 5, you have two options. You can do what's inside the parentheses first, which is adding, or you can distribute. So when you add first, you get 3 times 9, and you get 27. If you multiply first, you end up doing 3 times 4 plus 3 times 5, or 12 plus 15 equals 27. You get the same answer. The second method is what we call distribution. Okay, so let's do an example using the distributive property. So we have 4a squared over b multiplied by the quantity that's inside the parentheses. So we end up with 4a squared times b to the negative 2 all over b times a to the 4th power minus 12 times a cubed times b all over ba squared. Okay, now we can simplify and cancel here. So those b's are going to cancel out. A cubed over a squared is going to leave us with an a. Over on the other side, we have b to the negative 2, and b is going to leave us with b cubed on the bottom. And then that a squared and a to the 4th will cancel out, and we'll have a squared on the bottom. So our final answer is going to be 4 over b cubed a squared minus 12a. Let's do another example. Expand. So the first thing that I see is that b to the 0 is just going to cancel out because anything to the 0 power is 1 and we don't need to worry about it. So now we can do a to the negative 3rd times a squared bc all over c cubed minus 3 times a to the negative 3, a to the negative 2 over cb to the negative 2. We'll simplify from here, c cubed and c, that's going to leave us with c squared on the bottom. If we have a to the negative 3 and a to the positive 2, that'll leave us with a to the negative 1 on top. Over on the other side, a to the negative 3, a to the negative 2 is going to become a to the negative 5. And then we'll write what we have now. We have b over a times c squared. And then we have minus 3b squared. The b is going to come up. The a is going to go down to the bottom, so we have a to the 5th c. And that is our solution. Okay, solutions of equations. So if I have two examples here, 4 plus 3 equals 7, and 4 plus 3 equals 5. So obviously we've got a mistake here, or something's wrong. So we can say that the first equation is true, the second equation is false. Now, I'm just going to do some general math operations and we'll see what happens. So we have 4 plus 3 is 7. If I add a negative 5 or subtract 5 from both sides, I end up with 4 plus 3 minus 5 is 2, and 7 minus 5 is 2. So 2 equals 2. That is still a true statement. So even though I subtracted 5 from both sides, I still get a true statement. Now, if we do the same thing on the other side, 4 plus 3 equals 5. If we subtract 5 from both sides there, we end up with 2 is equal to 0, which is a false statement. So even when we added or subtracted the same amount to both sides, we still got a false solution. So if I have x plus 4 equals 6, and I subtract 5 from both sides, I end up with x minus 1 equals 1. Now, comparing x plus 4 equals 6 and x minus 1 equals 1, those are what we would consider equivalent equations because they still have the same value, but they're just different expressions. They still have the same solution set. So we have a couple of rules. The addition rule. The same quantity can be added to both sides of an equation without changing the solution set of the equation. So you can add or subtract from both sides without changing the value or the solution set. Okay, the multiplication and division rule. Every term on both sides of an equation can be multiplied or divided by the same non-zero quantity without changing the solution set of the equation. So basically all that's saying is as long as you multiply the same number by every term in your equation, you're going to keep the same value of the equation. So if I add 2 to both sides, it's not going to change the value. If I divide by 3 on both sides, it's not going to change the value, and I find that the value is equal to 4. Okay, so eliminate the parentheses. That's the first step in solving equations. The second step is you add like terms on both sides. The third step in solving equations, you eliminate the variable on one side or the other, eliminate the constant term on the side with the variable, and then eliminate the coefficient of the variable by dividing or multiplying. Okay, so we'll do a couple of examples. Solve. 12 minus 2x plus 5 equals negative 2 plus x minus 3. So the first thing we need to do is eliminate the parentheses. So we'll distribute that negative sign. 12 minus 2x minus 5 equals negative 2 plus x minus 3. Okay, then we need to combine like terms. So 12 minus 5 is 7, minus 2x equals, now negative 2 and negative 3 make negative 5, and we have x minus 5. Now we need to combine the variables on one side or the other. So in this case, we'll add 2x to both sides. So we get 7 is equal to 3x minus 5. Now we need to eliminate the constant term. So we'll add 5 to both sides. We get 12 is equal to 3x. And then the last thing we need to get rid of is the coefficient term. So divide both sides by 3. We end up with x equals 4. Okay. Let's do another example. Solve this equation. So the first thing that we will do is we will distribute. So 3 times 5 sixths is 15 sixths. 3 times 5 thirds is negative 15 thirds x. That equals positive 1/2 minus x. Okay, 15 thirds is 5, so we have 5x. And so we need to get both of the variables on the same side. So since we have negative 5x, we'll add 5x to both sides. So we have 15 sixths equals 1/2 plus 4x. We need to get rid of that 1/2. 1/2 is the same as 3 sixths. So 15 sixths minus 3 sixths is going to give us 12 sixths, which equals 4x. 12 sixths is the same as 2. Divide both sides by 4, and we get x is equal to 1/2. Okay, one last piece. Change sides, change signs. So if we have y equals 2x, y plus 2x equals 4, we know that we can add 2x or subtract 2x from both sides, and then you get y equals 4 minus, y plus 2x equals 4. Oh, sorry. I'm going to back up just a little bit. I got a little bit lost there. Okay, so when you have y plus 2x equals 4, you can subtract 2x from both sides, and we can tell that we'll get y equals 4 minus 2x. You can do the same operation without really thinking it through. So you should be familiar with doing this step already, but now the next step in Saxon math is to make it so that you don't have to think it through as much, so that it becomes more of something that you do automatically. And so this next thing that you can do is if you have y plus 2x equals 4, instead of thinking subtracting or anything, all you have to think about is getting rid of that 2x. So move the 2x to the other side, and then it's always going to change signs. So change sides, change signs. So move the 2x over, and it becomes negative 2x. So we'll do a couple of examples. So we have 2. We're just going to move that 2 to the other side, and since it's a negative 2, we're just going to make it a positive 2. So x equals 9. Let's do, and this operation is also called transposition. So if you see the word transposition in your set, that's what it's talking about. It's talking about switching sides, switching signs. Okay, so use transpositions to solve for p. So here we see that we need to get rid of some things. So we're going to switch over to the other side. We're going to move 3x over and we're going to move 4 over. The 3x is negative, so we're going to make it positive, and the 4 is positive, so we're going to make it negative. So we can just write p is equal to 7y and then plus 3x minus 4. You can do it all in the one step. Okay, solve for y. So we can use transposition to move those terms over. So 3y is going to be equal to 2x minus 5. And then divide everything by 3, so we get y equals 2/3 x minus 5/3.